it's Mrs. Pound, and I'm back for more of Chapter 1.2, Nature of Matter. We've talked about some characteristics of matter, and last time we talked about the kinetic theory. And what we're going to do now is we're going to apply the kinetic theory to the states of matter, and we're going to start that with solids in section 1.2.3. So our objectives today are to contrast solids with the other phases of matter, to explain how solids maintain their shape, and compare and analyze types of solids. So let's get started. So solids are the state in which matter has a definite shape and a definite volume. They hold their shape and they maintain a certain volume that we can measure. And we were doing that in class when we were measuring density. We also had to figure out the volume, either by using the formula V equals length times width times height, or by using a graduated cylinder. So the things that we were finding the volume of were solids. The reason solids have a definite shape and a definite volume is because there is a force of attraction between them called cohesion. And that force of attraction is between particles of the same kind of like these puzzle pieces in the picture below. They're the same shape and they fit together and they, I guess, attract each other. That's kind of what I was trying to get at, to give you a visual of that. But particles of the same kind can have an attraction for each other, and when they do, we call that cohesion. And this is true of solids. They are cohesive. Co meaning together, okay? Hesion meaning attaching, like in an adhesive. Now, the molecular structure of a solid and how it relates to its properties, there are three things. The first is that the particles of a solid are packed closely together, kind of like these marbles in this picture. They're really close together. Now, according to kinetic theory, they are moving, but they are just shaking in place. They're moving, they're shaking in place, and remember, their temperature, as their temperature goes up, they will move more. And as it goes down, they will move less. They'll shake in place less. The second thing we need to know about solids is they cannot easily move or flow over one another. And so I chose the picture in the background because we see that there are icicles on this hillside that the water was flowing at one point, but when it became a solid, they froze and they now cannot move or flow. So solids cannot easily move or flow, just like these icicles on this hillside. And the third thing we need to know about solids are generally hard or rigid with a definite shape and volume. So, and that was in the definition, but also the hard and rigid part. And so you see this hard, rigid brick wall with a definite shape and a definite volume for each of those blocks in the background. There are two types of solids. The first is a crystalline solid, like the snowflake in the background. These are solids whose particles are arranged in a regular, repeating three-dimensional pattern, like the snowflake, and has a specific melting point. That means that when it hits a certain temperature, it all melts. Just like ice. Ice melts at 0 degrees Celsius. It doesn't melt over a range of temperatures, it melts at 0 degrees Celsius. If you were to put a thermometer in a glass of ice water that's stirred well, it will stay at 0 degrees Celsius until all of that ice is melted. There will not be a range of temperatures. And some examples of this, like I just said, are ice. Salt is a crystalline solid. Diamonds. Many minerals are also crystalline solids when we talk about earth science. There are also amorphous solids. Amorphous meaning not really having a shape, okay? And these are solids with a random particle arrangement. They have no defined melting point. So they're not in that nice crystal structure. They don't form nice crystals like salt and ice with snowflakes do. Some examples are plastic, wax, and glass. And now these things, and you know this with wax, they don't have a defined melting point. They melt over a range of temperatures. For instance, wax starts to become soft at lower temperatures, and then it will continue to melt over a range of temperatures. It won't stay at one temperature as it melts. So that is the difference between an amorphous solid and a crystalline solid. And plastic will do the same. Also glass. When we look at glass, there's no crystal structure there, which is a good thing because it's clear and we can see through it. If it had a crystal structure, it might be boxy or something, and it would be more difficult to see through that glass. So our objectives today were to contrast solids with other phases of matter. Actually, that will be ongoing as we talk about the other two phases of matter, to explain how solids maintain their shape, and that's through cohesion, an attraction between the particles in the solid, and to compare and analyze types of solids, and that was the crystalline and the amorphous solids, and the fact that the big difference between them is their structure. One is more structured than the other, the crystalline, and their melting points, where crystalline has a specific melting point, amorphous solids do not. So I'll be back to talk about liquids and gases with you in other videos.